Okay, another way that we can do example 4, because remember we want to get rid of those fractions, is to actually create fractions that have a common denominator. So I'm going to go ahead and put this 2 over 1 so I can see the denominator is 1. My least common denominator is going to be 8. So I want to make every single fraction have a common denominator of 8. Here my common denominator is already there, so I can leave it. Here I want that to be 8, so 4 times what will give me 8? That has to be a 2, and whatever I do to my denominator I have to do to my numerator. So 3 times 2 is 6. Here I have a denominator of 1. I'm trying to get it to be that 8 again, so I have to multiply by 8. Whatever I do to the denominator, I have to do to the numerator. Okay? Similar to the other way that we did example 4, we can multiply by our least common denominator. What's nice about this is because I'm dividing by 8, my inverse operation is multiplication. So when I multiply each term by 8, it'll actually cancel out the fact that we were dividing because they're inverses. So I'll be left with just the numerator, negative 3x minus 6 equals 16. Then it becomes just like example 1 and 2. I want to get this x by itself, so I add 6 to both sides and divide by my negative 3, again being careful that that is multiplication, so my inverse is division, and I get the same answer. Yay!